And welcome to this exciting PLC Goods video tutorial series led by yours truly, Syed Reza Fattahzadeh, an industry experienced and education lover with over 20 years of hands-on experience in the dynamic world of industrial automation. In this video, I am excited to introduce you to a very brief explanation of each of the 24 lessons in our course, complete Delta PLC Programming course with ISPSoft and Factory I/O software. Our course is a complete journey made up of an impressive variety of 24 video lessons that will involve you deeply for a grand total of about 6 exciting hours. Throughout this adventure, you will uncover the art of mastering the details of programming the famous Delta PLC processors. We will explore the second generation WPSX2 series of PLCs manufactured by Delta Electronics Company. You won't just be an observer. You will actively participate using related simulators or even your PLC trainers. Each step is carefully recorded, ensuring your journey is trouble-free and easy as we explain fundamental tools such as DVP-20SX2 PLC, related simulators, and Factory I/O software, making it the simplest course to becoming a skilled PLC programmer, even if you don't have a physical PLC available to you. So welcome joining us, and thank you for choosing to begin on this amazing learning adventure with us. Let's not wait any longer and start lesson number 1 right away. Video lesson number 1 provides an overview of the industrial automation pyramid, introduces the PLC hardware, and explains its compatibility with WPLSoft and the advanced ISPSoft software. We explore the Delta product lineup, showcasing a specific PLC model with 20 inputs and outputs. The video covers the components of the PLC, its communication ports, and LED indicators. It also discusses wiring diagrams and the importance of selecting the right configuration for digital inputs and outputs. The video showcases creating a simple program in WPLSoft to activate a signal lamp using a switch. The software options WPLSoft and ISPSoft are presented for programming the PLC. The video ends by suggesting the advanced capabilities of ISPSoft, which will be the primary tool in future tutorials. In lesson number 2, we investigate in ISPSoft for reading and testing PLC programs, and we discuss the importance of COM-MGR for communication settings. We showcase testing programs with both real and virtual PLCs and briefly touch on the HWConfig interface for a specific PLC configurations. We begin by using WPLSoft to create and test the program and then transition to ISPSoft. We show how to set up a project, connect to the PLC, and upload a program. The process for simulating programs without a physical PLC is also explained. We provide a brief introduction to the HWConfig interface for modular PLCs. Lastly, we create and test a simple program highlighting the importance of default hardware settings. In video lesson number 3, We examine fundamental ideas like software, hardware configuration, simulators, and connecting to Delta PLCs. Our focus shifts to PLC programming, starting with fundamental commands. We test basic logic, explore different contact and coil types, and highlight the importance of adding symbols and comments for program simplicity. The video begins with transferring the PLC program to a computer and creating a new project. We use ladder diagram language to write programs, showcasing AND, OR, and NOT logics. We introduce set and reset coils for output control and explore pulse detecting contacts. We finish the lesson by highlighting the use of symbols and comments for program understanding. In video lesson number 4, we guide viewers through the process of connecting factory I/O software with Delta PLCs. The video covers key steps including PLC program creation, the introduction to factory I/O, setting up an OPC server using KEP Server EX to bridge the connection between the Delta PLC and factory I/O, and creating tags for monitoring and controlling the PLC inputs and outputs. We show how to connect factory I/O to the OPC server and connect tags with matching elements in the factory I/O simulation. The video concludes with a test showing how the PLC program interacts with factory I/O to control industrial equipment, showcased by turning on a belt conveyor. This tutorial offers a complete guide for users to merge Delta PLCs with factory I/O for industrial process, simulation, and control. The video concludes with showcase of how the PLC program and factory I/O interact to control the industrial equipment, such as turning on a belt conveyor. The tutorial provides a complete guide on how to set up the communication between Delta PLCs and factory I/O, enabling users to control and simulate industrial processes. In video tutorial lesson number 5, we show how to create a practical project for sorting boxes by height using factory I/O and a connected PLC. The key steps include a primary system test, brief mentions of an OPC server, manual testing and adjustments, PLC program modifications, sensor integration, introduction of additional devices like a warning light and alarm siren, and the execution of a PLC program. Tags are defined for PLC addresses in the OPC server, and factory I/O is configured to access these tags, enabling equipment control and monitoring. The tutorial provides a step-by-step guide for setting up the box sorting system based on height, highlighting the interaction between factory I/O and the PLC for a functional sorting mechanism. The video tutorial lesson number 6 introduces timer and counter instructions for PLC programming. The tutorial covers the basics of these instructions and how to use them. It includes practical examples of timer instructions, where timers are set and controlled using inputs and their state is used to control outputs. The tutorial also explains the use of counter instructions, where counters are set to count pulses and their values are compared to control outputs. Additionally, it provides insight into different types of timers and counters available in PLC programming. In short, the video showcases the programming process, highlights the memory addresses and instruction categories, and shows how to work with timers and counters. In video lesson number 7, I explained the implementation of a down counter using timer and counter instructions, and then apply these instructions to enhance a sorting box project. The tutorial introduces the idea of down counters using the DCNT instruction and shows how to set them up, including changing the counting direction using special bits of memory. The video highlights the importance of comments and addresses for simplicity in the program. It also addresses practical challenges such as controlling devices with small delays and making adjustments to ensure seamless operation. The video concludes with a brief explanation of the PLC program, including the use of timers, counters, set-reset instructions, and connection with an OPC server for monitoring. In the video lesson number 8, the focus is on data registration within PLC memory using different instructions. I start by explaining the different types of memory addresses in the PLC, highlighting the use of bit addresses for binary data and data registers for storing numerical values. The video introduces the increment and decrement instructions, showing their usage in modifying values within data registers. Special memory addresses, especially those in the latched category that retain values even after a power loss, are discussed. The program shows how these addresses are used for initial PLC settings, using the move instruction to store constants in data registers. The video also covers comparison instructions, including logical operations and different comparison instructions as well. In the video lesson number 9, the primary focus is on fundamental arithmetic operations, especially multiplication, division, addition, and subtraction. The video begins with a brief overview of these arithmetic instructions, highlighting their practical importance in Delta PLC programming. Various instruction types are explained, with differences noted, including their response to signal edges and data type requirements. The tutorial then examines a practical project using Factory I/O, showing how to control a water tank system. The project shows the interaction between the PLC and Factory I/O using an OPC server. The objective is to maintain the desired water level automatically, utilizing a potentiometer and a manual automatic mode selection. The video offers a detailed breakdown of the programming logic for the water tank project, showcasing the use of move, comparison, and arithmetic instructions to manage the tank's inlet and outlet valves in agreement with the desired water level. The insertion of a deadband ensures more seamless operation in automatic mode. The tutorial maintains a practical, real-world application approach. The video lesson number 10 focuses on loop control instructions, an essential feature of program flow control. The tutorial introduces the jump instruction and how it can redirect program execution, showcasing its ability to alter program flow. It goes on to explore interrupts, showing the creation and management of external interruptions using enable and disable interrupt instructions. The tutorial then examines creating loops with for and next instructions, explaining how they impact the scan cycle duration. It discusses extended scan times and introduces watchdog timer instructions as a solution for managing program execution time. Additionally, the video introduces functions and explains how to divide a program into modular parts enclosed within functions, allowing them to be called from the main program for efficient programming. Practical applications include a program controlling LEDs in manual and automatic modes. The video tutorial lesson number 11 examines transmission comparison instructions and enhances a water tank control project. It begins with the CMP instruction used for mathematical comparisons and Boolean address activation. It introduces related instructions like CMPP and DCMP, especially in the framework of double word memory. The XCHP instruction designed for data value exchanges is highlighted, along with a brief look at binary coded decimal format and the role of BCD and BIN instructions in handling large numerical values. To optimize the program, function blocks are introduced, facilitating modular programming. A function block is created to calculate water volume based on water level, offering integer and fractional outputs. The video concludes by seamlessly integrating the function block into the water tank control project, enabling the display of water volume over two digital displays. In video tutorial number 12, basic math instructions such as increment and decrement are covered. The video begins to explain the word logic instruction group. Starting with add, it is explained how this instruction performs addition with specific boundary conditions. The sub instruction for subtraction, along with its variations, is explained. The tutorial also highlights the use of increment and decrement instructions, highlighting the importance of sensitivity to rising signal edges. The word logic instructions and, or, not, and XOR are introduced for logic operations. A practical project involving 4 belt conveyors is displayed, showcasing the application of OR and AND logic with digital inputs. This efficient approach reduces duplication in the program and ensures convenient control of individual and collective belt conveyors. The video lesson number 13 examines the rotation and displacement instruction group in PLC programming. It covers basic instructions like rotation right and rotation left, which shift bits in memory, including instructions sensitive to positive pulses. Word shift right and word shift left instructions are introduced. The tutorial shows a practical project where water tank levels are saved in the PLC memory. Symbols are used for program simplicity, and latched memory addresses ensure data retention even in a stop mode. The program is created using a symbols defined in the local symbols table. Instructions like dMovR control analog valves, and the program calculates and stores water levels at regular intervals using a timer. The video also guides on connecting the PLC to factory I/O software with an OPC server. The video lesson number 14 examines the data processing instructions in Delta PLC programming. It covers commands like zone reset, decode, and encode for memory control and state representation using bits. The sum instruction calculates the count of ones in a specific address, while BON checks and activates outputs based on the state of a bit. The min instruction calculates an average from given inputs, excluding fractional parts, and SQR calculates square roots. Additionally, the video introduces Easy PLC and Machine Simulator 3 software, providing a brief overview. It shows creating, compiling, and testing a simple program in Easy PLC. The video lesson number 15 focuses on calculating the mean water volume within a tank simulated using Machines Simulator software. The presentation starts with testing the final project, showcasing digital and analog input-output statuses and enabling the control of inlet and outlet valves. The min instruction is introduced to calculate the mean water volume over time. The video then outlines the essential steps for project implementation, which include programming the Delta PLC using ISPSoft and COM-MGR software, setting up an OPC server with KEP server EX, and defining necessary tags for connecting the PLC and OPC server. Easy PLC software is introduced to control the design system, providing the flexibility to use both virtual and real equipment such as switches and push buttons. The video details the process of writing the PLC program to manage valves, sensors, and calculations. In the final part, the video explains the connection between Easy PLC and the Delta PLC and the successful testing of the project, ensuring a seamless link between the virtual system and a real PLC. In video lesson number 16, we explore high-speed processing instructions and implement a traffic light project using timers, counters, and PWM instructions. We also introduce a method for connecting Easy PLC software to an OPC server and a variable import feature. The video starts with the refresh instruction, which allows us to capture input states mid-execution. We then examine the refresh and filter adjust instruction, focusing on digital input filtering. Next, we learn about the speed detection instruction, which counts pulses and calculates motor speeds, and the PLSY instruction, which generates pulses. Additionally, we examine the PWM instruction for analog control. The video guides us through creating a traffic light project with normal and flickering modes. We use counters to toggle between these modes and design a detailed program with symbols for light control, timers, and comparisons for state management. The tutorial shows connecting to an OPC server through the Delta PLC and then simulating the traffic light system using Machines Simulator software. We import variables, configure tags, and ensure the system performs as expected. In tutorial lesson number 17, we examine high-speed processing instructions and focus on high-speed counters. Initially, general counters like CNT and DCNT are reviewed and introduced by means of examples. The difference between 16-bit and 32-bit general counters is explained with insights into their counting directions. The tutorial transitions to high-speed counters, highlighting their 32-bit nature, requiring DCNT instructions. The video highlights the advantages and disadvantages of software and hardware high-speed counters in terms of reliability and CPU resource usage. Presentation programs for both software and hardware high-speed counters are created, showcasing their functionality, immediate responses, and use in generating interrupts. In tutorial number 18, we examine general counters and show a simple project. The project simulates a system involving digital inputs, push buttons, and photocell sensors aiming to fill boxes with apples. A 16-bit counter tracks the number of start requests, enabling a flashing output after a set number of starts. Conveyor control logic and system activation conditions are detailed. The tutorial emphasizes the connection of virtual elements to real digital inputs by means of an OPC server allowing the project execution. After discussing program download and connection to the OPC server, a showcase within Machines Simulator software highlights the project functionality and the importance of correct tag placement. The tutorial concludes with a showcase of the system's operation, presenting the use of counters in a practical application. The video lesson number 19 showcases the practical application of two handy instructions in a machines simulator project, especially focusing on a mixing system. Inputs such as push buttons, level sensors, and control valves are used to manage the system. The ALTP instruction toggles memory bits for start-stop calls controlled by a push-button link using an OPC server. The project involves discharging, filling, and mixing modes with precise conditions for valve operations. A second push-button influences the mixer runtime during cycles. A TTMR instruction tracks expired time for a mixer activation. Tutorial explains that during presentation in WPLSoft, the program can be adapted to ISPSoft software. Self-learning tips are provided, spotlighting using the help window and referring to the comprehensive WPLSoft user manual accessible on time. The video number 20 examines analog signal applications, starting with the uniqueness between digital and analog inputs, outputs in industrial framework. It showcases the use of potentiometers as analog devices, with each one connected with a specific memory bits and data registers. The video presents a program where potentiometer values affect digital outputs based on defined thresholds. The tutorial then examines the implementation of built-in analog inputs and outputs on a Delta PLC, highlighting signal scaling and the relationship between signal voltage current and memory values. The video extends on configuring and scaling analog outputs, showing how to generate precise voltage levels using mathematical instructions. Additionally, it showcases the utilization of extension modules for extra analog inputs and outputs, guiding users on setting up modules, mapping signal types, and employing to and from instructions. The tutorial lesson number 21 shows the integration of a Delta PLC with factory I/O software, enabling control of a virtual water tank system using an OPC server. The primary focus is on programming a PLC to translate real values from the virtual water tank, convert them into centimeter measurements, and control the filling valve. The program includes two networks. The first converts real values to integers for display, and the second processes the potentiometer input to regulate the filling valve. Network description enhances program simplicity. The tutorial concludes with a practical test in Factory I/O, showcasing real-time PLC virtual system interaction. Successful OPC server connections show practical validity, placing the foundation for future tutorials, including advanced PID controller implementation. The tutorial lesson number 22 examines PID or proportional integral derivative controllers and their practical implementation in ISPSoft. The main focus is a real-world project showing the utilization of a PID controller to regulate water levels in a tank using Factory I/O software. The project includes two networks. The first computes and shows water levels based on a level meter signal, while the second introduces PID control for automated level regulation. The video fully covers PID controller fundamentals, including set points, process values, and PID parameters stored in specific data registers. Clear guidance is provided for parameter configuration with a focus on proportional integral control and integral variables. Fine-tuning PID variables for optimal performance is highlighted, showcasing how the controller responds to different scenarios. The video also showcases the seamless integration of the PID controller with Factory I/O, CapServer EX software, and the PLC, explaining OPC server tag creation and virtual system interactions. The tutorial concludes in a comprehensive project test underscoring the PID controller's ability to maintain the water level at the desired set point while efficiently managing the filling and discharging valves. In video tutorial lesson 23, we examine the SFC or Sequential Function Chart programming language, ideal for dividing industrial processes into manageable steps. We explore the key components, steps with associated actions, transitions with logic conditions, and directed links between them. A practical example involves a water tank system showing the SFC program's operation. We discuss SFC's graphical representation and how to create sequential charts with meaningful step addresses. Actions, which define each step's tasks, are explained, and a simple program is developed for each action. Transitions are introduced to determine when the PLC should progress from one step to another utilizing conditions and timers. The tutorial covers compiling, transferring programs to the PLC, and starting the SFC chart. The video concludes with a demonstration of a Factory I/O project linked to the SFC program, showcasing the dynamic control of a water tank system. In video lesson number 24, we examine human-machine interfaces or HMIs and their integration with Delta PLCs. HMIs, necessary and fundamental in industry, enable real-time data display and user interaction by means of graphical interfaces. We showcase the process of connecting an HMI to a Delta PLC using Easy Builder 8000 software. We highlight the significance of physical connections by USB and RS-485 and spotlight Easy Builder 8000 for HMI programming and configuration between the HMI and PLC. HMI design includes bit lamps, techs, toggle switches, meters, sliders, and bar graphs. Ensuring proper connections and data exchange, we transfer the compiled design to an HMI. Real-world testing allows HMI control of LEDs, numeric values, and links to factory I/O using an OPC server. This tutorial provides or enables viewers for HMI PLC integration in industrial settings, enhancing HMI design and PLC programming skills. Conclusion of this video. My PLC programming course, composed of 24 lessons, investigates deeply into Delta PLCs and their application in industrial automation. Each lesson offers practical insights covering topics from basic ladder logic to advanced principles like PID controllers and sequential function charts. The course showcases seamless integration with factory I/O and human-machine interfaces, highlighting effective communication in industrial frameworks to allow you to confidently tackle real-world automation situations. You can access each full lesson video for free by clicking on the corresponding link provided in the video description right below. To master the skills of a professional PLC programmer, carefully observe, practice, duplicate, and copy or imitate each topic covered in my video lessons on your PLC or simulator and test it for yourself. Discover further by purchasing the complete video course at www.plcgoods.com, where you will unlock following priceless and important benefits. 1. Code lessons that enhance your understanding or insight of each program logic. 2. Direct access to my WhatsApp channel for customized and specialized support. 3. Ask questions and receive guidance tailored to your needs. Thank you for being a part of this educational journey. These video lessons are carefully crafted to clear the road for your future success in industrial automation. Best of luck, and may your programming activities be both fulfilling and rewarding. See you. Take care.